Hi. The purpose of Lab 3 was to observe the pushes and pulls of a star as it orbits a black hole. Using the fundamental principle, we know that dp dt equals dp dt parallel plus dp dt perpendicular. The assumption is made that F net is due to a single force, being the gravitational pull of the black hole. The results of the lab show that the trajectory formed an ellipse with the black hole positioned towards the inner right side of the ellipse. Viewed in the motion analysis, with the black hole having a mass of 3.7345 times 10 to the 31 kilograms. To calculate this, we use the equation magnitude of F net equals g, the gravitational constant, times the mass of the star times the mass of the black hole divided by the magnitude of the distance squared. G is gravitational constant 6.7 times 10 to the negative 11 newtons times meter squared divided by kilogram squared. The mass of the star is given on Weber sign as 1.989 times 10 to the 30th kilograms. The R value, being the distance, is found by subtracting the position of the black hole by the position data given by the position data and subtracted by the position data of the star given in the star data file. F net, the magnitude of F net, is given in the output file of your VPython code. Now, looking at the code, which I've enlarged here, some of the essentials we have is the mass of star.m, being 1.989 times 10 to the 30 kilograms, set here. Delta t, the time step, is 86,400 seconds. Now, xvel and yvel are based on the fact that we know if we have n positions, we can calculate n minus 1 velocities. These velocities were then used with the mass to calculate momentum. dp dt is the change in momentum with respect to time, which we have highlighted here. Now, going to my code, if I run it, we can see here that the yellow arrow points towards the black hole, suggesting it represents F net. The blue arrow points perpendicular to the motion of the trajectory, suggesting it represents dp dt perpendicular. And the black arrow points parallel to the direction of the motion, suggesting it represents dp dt parallel. Now, moving on to the what if and what does it mean questions. What does it mean? How are F net perpendicular, F net parallel, and F net different from dp dt perpendicular, dp dt parallel, and dp dt? Well, the change in momentum is a component that is observed based on the total net force, while F net is the sum of all the pushes and pulls. So basically, momentum is only something that can be observed. It's not something that you can just calculate based off of just looking at it. It's solely based off of F net, which is what's calculated based on the sums of all the pushes and pulls, which is essentially why they are different. Now, moving on to the what if question. Imagine the black hole whose mass you found was removed, and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? Well, the trajectory of motion would still remain the same. Therefore, the mass of both black holes is the same. Therefore, you cannot tell the difference between the black holes. This concludes my presentation. Thank you for your time.